All right, everybody, sorry I can't be with you today. I'm just not feeling good, so I put together this video to help with the new content. So writing exponentials, we need at least 2 points. There could be more. I'm just going to use these two here, 0, 2, and 2 comma 4.5. And if we know it has to be of the form f of x equals a times b to the x, remember that the x coordinate is 0, and then your output, or y, or f of x is 2. So I can make that substitution. Wherever I saw f of x, I can swap it out with 2 equals a times b to the 0. And hey, b to the 0 is pretty nice. That's just 1. 1 times a is just a, so a equals 2. This should not be a surprise, though, because we knew the y-intercept. We're not always going to be fortunate to get the y-intercept in the equation, but it kind of just confirms that, yeah, we were expecting that to be 2. All right, so we call that round 1. For round 2, it might seem like we're starting off very much the same, but this time we know a is equal to 2. And we're going to use the other point, which is 2 comma 4.5. So 4.5 equals 2 times b to the 2. So that's 4.5 equals 2b squared. I'll divide both sides by 2. That should be 2.25. And if you know your perfect squares, the square root of 225 is 15. So technically b would be the plus or minus square root of 2.25, which is really plus or minus 1.5. And because this is exponential growth from left to right, we're going to ignore the negative and only accept the positive 1.5. Notice there's no k value because the horizontal asymptote is here at 0. So the final answer would be f of x equals the a value we found, which was 2, times the b value we found to the x. Feel free to rewind or watch again if you need to. Okay. I want to do one more with you, in which the horizontal asymptote is not at 0, because you do have to account for that in your equation. And just by first glances, it does, let me zoom in here. The horizontal asymptote appears to be at -5. So again, kind of my round 1. I always use the point furthest to the left. So f of x equals a times b to the x. But we have to remember that -5 to account for. So if we use -127, so 27 equals a times b to the -1, and I still have that -5. To get rid of that -5, I'm just going to add 5 to both sides. And then b to the -1 is really just, it moves to the denominator as b to the +1. Kind of like a proportion you can cross multiply. So I got a equals 32b. It's not ideal, but we can still operate with it, as we'll see here in just a second. All right, so round 2. So f of x equals a times b to the x -5 for that horizontal asymptote. And this time, we know that a is equivalent or equal to 32b. So before I sub in a second point, I'm going to say, okay, I don't know what a is just yet, but it's going to be 32 times b to the x -5. And now I'll use the second point here. So again, this is like your x and your f of x. So negative 4.5 equals 32b times b to the second minus 5. I'll start reverse PEMDAS by adding 5 to both sides, so that's 1/2. And then 32b times b squared, we add the exponents, so 32b to the third. From here, we want to get b by itself, so we can multiply both sides by 2 to clear the fraction. I'll divide by 64. And then the cubed root of this is actually really nice because 1 and 64 are both perfect cubes, so your b value is going to be 1/4. They might think, hey, we're done, and we're awfully close. The only thing we're missing, put the horizontal asymptote there, is the a value. So you've come all this way, let's finish it. So, hey, if a is 32b, and we know b is 1/4, I can make another substitution right here and say that a is 32 times 1/4, and 1/4 of 32 is 8. I really hope to be back in class with you tomorrow. Have a great day and take care.